Okay. In the last lecture, we have discussed about the Newton divided difference interpolating polynomial. In Newton divided difference and Lagrange interpolating polynomial, nodes are not required to be equally spaced. Okay. Now we are arranging nodes in equally spaced form. Then we can get different formula or the modified formula that we can call as Newton forward formula or backward formula. So that the nodes are arranged consecutively with equal spacing say H. Okay. Let us suppose the nodes are x0, x1, x2 up to xn. Okay. xi plus 1 minus xi equal to h, or I equal to 0, 1, 2 and minus 1. So nodes are separated to each other by the spacing h. x1 can be written as x0 plus h, x2 as x0 plus 2h, or xi we can write it as x0 plus ih. Let us suppose x is belonging to the interval x0 to xn. X is any point inside the interval x0 to xn and different from xi, then x can be written as x0 plus sh, x0 to plus sh. Then we can write x minus xi as x0 plus sh. S is some parameter, x0 is the initial point and h is what? That is the spacing. Then the value of x is what? x0 plus sh, and xi is what? x0 plus ih. What is the value of x minus xi is coming out to be s minus I into h. Now, what we are doing here, we are arranging nodes point in such a way that the spacing with, like actually in Newton divided difference and Lagrange formula, there was no restriction with the node points. Okay, there may be nodes may be equal, or it may equal in spacing, or it may not. But here now we are doing what? Whenever the nodes are at equal spacing, suppose h, then we can modify Newton divided difference formula into a different form. How we can do that? What is Newton divided difference formula? Newton divided difference interpolating polynomials. Divided difference interpolating polynomials. Interpolating polynomials. Newton divided difference interpolating polynomials. What is that? Just recall previous lecture. Interpolating polynomial. That means p and x equal to f of x0 plus x minus x0, f of x0, x1, x minus x0, x minus x1, f of x0, x1, x2 and so on, plus x minus x0, x minus x1, x minus xn minus 1, f of x0 to xn. Now x minus x0 is what? The value of x is brought in from the previous consideration, x0 plus sh, x0 plus sh. minus x0, it is coming out to be sh. X minus x1 as x0 plus sh minus x0 plus h, s minus 1 into h. Similarly, we can compute x minus xi as s minus I into h. Now put the values of x minus x0, x minus x1, x minus xi in this polynomial. So what is coming out to be Pn x0 plus sh equal to f of x0 plus sh f of x0 x1 plus s into s minus 1 h square f of x0 x1 x2 and so on plus s into s minus 1 s in minus n minus 1 hn f of x0 up to xn and so on. This is Newton divided difference for equally spaced points. What is S? S is x minus x0 upon h. X is any point inside the interval x0 to xn, different from these xi. Okay. Now Newton forward interpolating polynomial. Interpolating polynomial. Somewhere. Okay. Newton forward interpolating polynomial. So this is the formula. We'll just modify this formula. Okay. What is Newton forward interpolating polynomial? For that first we'll introduce forward operator. If we are writing del of fx, that means we have to go next forward step and then at the same step. That means f of x plus h minus f of x, that is the forward operator definition. Backward operator definition is what? F of x del of fx. This is called forward operator. Forward operator. This is if we are writing delta downward, then it is backward operator. Backward operator. What is del of fx? That is f of x, same point and one step backward, f of x minus h. If h is the spacing between the two nodes, we can say. Okay. Now Newton forward interpolating polynomial. What is Newton forward interpolating polynomial? We can write f of x0 x1. Okay, f of x0 x1 is what? F of x1 minus f of x0. It is nothing equivalent to the function value x1 minus x0. So f of x1 minus x0 is what? That is f of x0 plus h. Okay, this is 0th order divided difference, so it is equivalent to the function value, since x1 equal to what? x0 plus h. That's why we are writing x1 x0 plus h minus f of x0. Okay, upon x1 minus x0, that is what? The spacing is h, we have assumed already. Okay, we have already assumed that the difference between the consecutive points are what? That is h. Okay, so this is coming out to be what? F of x0 plus h minus fx net. This is from the forward operating definition, del of fx0 upon h. So the value of fx0, fx1 is what? Del of fx0, fx1. Next is the value f of x0, x1, x2, f of x1, x2 minus f of x0, x1 upon x2 minus x0. What is the value of x2 minus x0? x2 minus x0, that is 2h. Okay, and the value of fx1, x2 from the previous set, x0, x1, del fx0 upon h. When this is x1, x2, then f of x. then del of fx1 from the previous section minus del of fx0 upon h upon h upon 2h. Since the value of f of x0 x1 is what? F of x1 minus f of x0 upon x1 minus x0. The value is what? F of del of fx0 upon h. So this is the value. Similarly, the value of f of x1 x2, it is del of fx1 upon h. So that's how we kept this value. So del we take outside, f of x1 minus f of x0 upon 2h square. So del fx1 minus fx0, x1 is what? x0 plus h. This x1 is what? x0 plus h. So this is the forward step. So del, we can write it del of fx0. How? We have assumed that f of x0 plus h minus f of x0, it is equivalent to del of fx0. Upon 2h square, del square fx0 upon 2 can be written as factorial 2, doesn't matter, h square. So this is the value of fx0, x1, x2. Similarly, you can compute the value of f of x0, x1, x2, x3. The value is coming out to be del c fx0 upon 3 into 2 into 1 into h cube. Okay, so del cube fx0 upon factorial 3 h cube. Similarly, you can compute the value of f of x0, x1 and xn equal to del n fx0 upon factorial n h raised to power n. Now put all the values of into this formula. This formula is what? This is the Newton divided difference formula for equally spaced point. Okay. So this is the Newton divided difference formula for equally spaced point. When the points are equally spaced, then only Newton forward or backward can be applicable. So can be applied. So we are having equally spaced points. So just put the value of fx0, fx0 x1, f of x0 x1 x2 from here. Okay, what the formula is coming out to? P of x0 plus sh equal to f of x0 plus sh del of fx0 upon h plus sh s minus 1 into h del square fx0 upon factorial 2h square plus s minus 1 s minus 2 h cube del cube fx0 upon factorial 3 h raised to power 3 and so on plus s minus 1 s minus n minus 1 del n fx0 upon factorial n h raised to power n and also h raised to power n. So you can say this can get cancelled. All the numerator and denominator containing same power of h, they get cancelled. So what you are getting here Pn x0 plus sh equal to f of x0 plus s del of fx0 plus s minus 1 del square fx0 and so on plus s into s minus 1 s minus n minus 1 del n fx0. upon factorial 2 upon factorial n. So this is called Newton forward interpolating polynomial. Why forward? Because this formula involves forward operator. That's why. Okay, so Newton forward interpolating polynomial. So this is the particular case of Newton divided difference formula. This is the particular case of Newton divided difference formula. That is for unequal Newton divided difference formula for unequal nodes point. Next is when the points are equally spaced, then Newton forward formula we can derive from Newton divided difference. Next is Newton backward formula. Newton backward formula. Newton backward formula. Whenever the Newton forward and backward, they are based on forward operator and backward operator. Okay, so arranging nodes from backside like xn, xn minus 1, xn minus 2, x2, x1, x0. Okay, now x is any point that is belonging to the interval x0 to x1. Then x can be written as, x is any point inside this, we can write as xn plus sh. Okay, we are arranging nodes from back to forward. So first we'll write xn, then xn minus 1, xn minus 2, and the point x0 in the last. So x is any point inside the interval, then x can be written as first point here now xn plus sh. S is a parameter. If S is lying inside this interval, then S will be what? Between 0 and h. If it is here, then 0 to 2h, like that. So x is any point different from these xi point. Now we can write x equal to xn plus sh, then xn minus 1 minus xn will be what? Just write this point minus this one, which is coming out to minus h, or we can write as xn minus 1 as h. Okay, now we can write x minus xn minus 1 xn. What is coming out to be? X is what? Xn plus sh minus xn. This is the point is sh. X minus xn minus 1. What we can write here? Xn plus sh minus, we can write xn minus 1. So what is coming out to be? xn minus 1 plus sh. This is what? Xn minus 1 is what? That is h plus sh. The value is coming out to be s plus 1 into sh. So x minus xn minus 1 is what? This is the value. Now x minus xi. It will be what? S plus I into h. You can compute it on the similar pattern. Okay, so x minus x0 will be what? That will compute accordingly. So this is when xn minus 1, so this s plus 1 into h. Xn minus 2, x minus xn minus 2, s plus 2 into h. X minus xi, that means what? S plus I into h. So just So writing Newton backward formula, writing Newton divided difference formula, Newton divided difference formula for polynomials, taking notes from xn to xn minus 0, taking notes xn, xn minus 1, x0. Okay, so what is the formula? Pn x equal to f of xn plus x minus xn, f of xn, xn minus 1, x minus xn, x minus xn minus 1, f of xn, xn minus 1, xn minus 2, and so on. X minus xn, one point last here, up to x1, f of xn, xn minus 1, up to x0. Okay, so f of xn as it is, x minus xn that we computed from here, x minus xn, this value, sh f of xn, xn minus 1 plus s into s minus 1 h square f of xn, xn minus 1, xn minus 2, and so on, plus s, this is s plus 1, s plus 1, s plus 2, s plus n minus 1, h raised to power n, f of xn, xn minus 1 up to x0. Okay, this is Pn xn plus sh. This is also the modification, or like this is also the Newton divided difference formula, because divided difference is involved here when the notes we are taking from backward to forward, from xn to x0. Now backward operator we have already discussed. Backward operator, so f of del of fxn, del of fxn, that is equal to what? If we are writing del of fx, what does it mean? F of x minus f of x minus h. That means where you are standing, f of x, and go backwards, one step back from that position. So f of x minus f of x minus h. So now write divided difference in term of backward formula. F of xn, xn minus 1, f of xn, xn minus 1. You can write it as f of xn and xn minus 1, that is coming out to be f of xn, f of xn. According to the divided difference formula, xn minus 1 minus xn, we can write it f of xn minus f of xn minus 1 upon xn minus xn minus 1. F of xn minus 1, that means what? This is xn position, and backward xn minus 1 is the backward position. So it is what you can write it as del of fxn upon h. This is the value of f of xn, xn minus 1. Similarly, we can write the value of xn, xn minus 1, xn minus 2 as del square fxn upon h square, that is 2h square. Similarly, the value f of xn, xn minus 1, x0 as del n f of xn upon factorial n h raised to power n. Just put the values of these divided difference into this formula, and what you will get? You will get formula as Pn x equal to f of xn plus sh f of xn minus 1. Just put the value of xn minus 1. What is the value coming out to be? Del of fxn upon h. As here you are having s plus 1. In the forward formula, this is s minus 1. Del square f of xn upon factorial 2. Okay, h is cancelled. I am not writing those terms. S plus 1, s plus 2, and so on, s plus n minus 1. Del n f of xn upon factorial n. So this is the Newton backward formula. For equally spaced points. Okay. So let's do one example based on it. Let's do one example. Generate the forward difference table and find interpolating polynomial to the data. X equal to 0, 0.2, 0.4, 0.6, 0.8 data, and hence interpolate the value at f of at 0.1. Okay, the value of the function is 0.12, 0.46, 0.14, 0.90, 1.2. Okay. Now form forward difference table. Okay, just a minute. So forward table 0.46 minus 0.12, this coming out to be, that is 6 minus 2, 0.34. Here just a minute. Minus 0.12. Should be 0.74 with some calculations. Okay, so now find out these values. This value is coming out to be 0.446, 0.74. This value is 0.28, 0.16, 0.30. Using these values, it is coming out to be minus 0.06. This value is minus 0.12, 0.14. This is del square fx. Del cube fx minus 0.12 plus 0.06. This value is coming out to be minus 0.06. Using these values, 0.26. Del 4 fx 0.32. Okay, so now compute the value of the polynomial. So first what is the polynomial? X0 plus sh equal to f of x0 plus s del of fx0 plus s into s minus 1 del square fx0 and so on. Okay, what is the value of fx0? This is the value. So here we'll concentrate only the first value of the table, first value of the all column. Okay, for applying forward difference formula. So first we'll compute the value of s. S is what? X minus x net upon h. What is x? X here 0.1, where the value we have to compute. What is x naught? X naught is the first value of x, that is 0, and h is what? Spacing, that is 0.2. So what is the value coming out to be? 0.1 upon 0.2, that is 1 by 2, that is 0.5. So s is completed. Now put the values of s and factorial 2. Now put the values inside the formula. So what you will get? You will get here Pn 0.1 as x0 plus sh equal to, and 0.12 plus what is s? S is what? 0.5, that is 1 by 2 or 0.5, 0.34 plus 1 by 2 into s minus 1 by 1 by 2 minus 1, and the value is what? Minus 0.26, 0.34 minus 0.06, 06. Okay, now we'll put all these values into the formula. Finally what we'll get? We'll get P 0.1 is equivalent to 0.28125, or we can say f of 0.1 is equivalent to 0.28125. So just put all the values into the formula and get the result. So that's the value. Next is the difference between the forward formula and backward one, when to apply. Whenever we have to compute value from the forward data, then we'll use Newton forward formula. If the value we have to evaluate from the downward side of the data, then we'll use Newton backward formula. As we have here in this case, we have to compute the value 0.1, that is lying inside the forward value. Suppose we have to compute value inside the interval from 0 to 0.4. So we'll use forward formula. If we have to compute the value from 0.4 to 0.8, that means it is below the middle point. So we'll compute value with the help of backward formula. Suppose you have to compute, f as 0.7. Okay, so what you will do? In that case, you will apply Newton backward formula. Okay, let us suppose the value you have to compute, that is what? As 0.65. Better to take, because I have calculation for this, 0.65. So in this case, now apply backward formula. Why backward formula? Because value is lying in the downside of the data given. So same table will work. Now for downwards, these values will be used. Okay, so this is what? This is the value of del of fx0. This is the value of del square fx0. This is the value of del cube fx0. This is del 4 fx0. Sorry, I have done little mistake. This is del. This is only fx0. F of xn. For backward formula, we are using fxn. N is what here? 0, 1, 2, 3, 4. So n is here 4. So the value, this is del of f of This is the value of del q fx4. Okay, del q fx4. This is del 4 fx4. If we are using backward formula, if we are using simply forward formula, so this is the value of fx0, this is the value of del fx1, this is the value of del square fx1, this is del q fx1, and this is del 4 fx0. First point, about first point. So same table will be here. Now compute the value of s xn, because how to compute value of xn in backward formula. Apply backward formula. So in backward formula, we'll take x equal to xn plus sh. X is what? That is 0.65. Xn is what? That is the last point, 0.8. This is the last point, that is 0.8. S you have to compute, and 0.2. So the value of s is coming out to be 0.65. It will always be in negative. Okay, minus 0.8 upon 0.2. The value of s is coming out to be minus 3/4. Okay, now just put the formula. Pn P4 0.65 we have to compute. So the value of the function is what? That is 1.2 plus minus 3/4, 0.30 plus minus 3/4 minus 3/4 plus 1, because in the formula we are having plus 1, that is 0.14 minus 3/4 minus 3/4 plus 1 minus 3/4 plus 2 into 0.26 plus minus 3/4 minus 3/4 plus 1 minus 3/4 plus 2 minus 3/4 plus 3. The value is what? That is 0.32. After doing all the calculation, you are getting value that is equivalent to 1.080925. This is the value of P4, 0.65. So this is the difference. Okay. So this is the backward formula and forward formula. Whenever you have to compute value from forward side of the data, then forward formula, from backward side of the data, backward formula. Okay, if in between, so you can choose any value, any formula, maybe forward or backward. So this section is done. So interpolation portion is over. In the next class, we'll discuss about, in the next lecture, we will discuss problem based on interpolation. Thank you.